All right, let's dive in. Today, you're not just an engineer. Nope, you're an architect, and your mission, should you choose to accept it, is to build a completely impenetrable digital fortress in the cloud. Our building material of choice? Azure Kubernetes Service. Let's get to it.
So how are we going to build this thing? Well, we're going to construct our fortress in 5 key stages. First, we'll lay out the security blueprint. Then, we'll post guards at the gates to control who gets in. After that, we lock down the treasury. Got to protect that data. Next, we'll reinforce the walls to harden the whole structure. And finally, I'm going to give you the architect's checklist so you can make sure your own fortress is rock solid.
Okay, part 1, the blueprint. You can't just start throwing up walls and hope for the best. Every great fortress starts with a really solid plan.
But let's ask the big question. Is your cloud kingdom actually secure? Because without a solid plan, your cluster is basically a castle with no walls. It's just an open field, totally vulnerable, where one tiny misstep could lead to a massive breach. And that's exactly what we're here to fix. And let's be crystal clear about this. You are the architect. This isn't just about spinning up a few containers. It's about thoughtfully designing a secure environment right from the ground up. So yeah, your mission is to build that impenetrable AKS fortress. So let's talk about our first line of defense, guarding the gates. It's simple, right? A fortress is only as strong as its gatekeepers. This whole section is about controlling who can even approach your cluster, and more importantly, what they can do if they get there. Our main gate is something called Entra ID. You might know it by its old name, Azure Active Directory. Hooking this up with AKS connects your company's entire user directory straight to your cluster. This basically means only authenticated users from your team can even knock on the door. It answers that first critical question. Who are you?
But just knowing who someone is, that's not enough. Once Entra ID confirms their identity, we need another layer. That's where Kubernetes Role-Based Access Control, or RBAC, comes in. Think of RBAC as the guard inside the gate who checks their paperwork and asks the next important question. Okay, you're on the list, but what exactly are you allowed to do in here?
And this right here just shows you the power of being specific. Giving everyone cluster admin rights? That's insane. It's like handing out the master key to the entire castle to every single person. A single compromised account could lead to a total takeover. The secure way, the smart way, is the principle of least privilege. You give each person only the keys they absolutely need to do their job, and nothing more. Simple as that.
All right, the gates are guarded. Awesome. Now we need to move inside the walls to protect the crown jewels, the treasury. In the cloud world, the treasury is our data, and this is all about securing how our applications, our workloads, get access to it.
So let's paint a picture with a super common scenario. You've got an app running in a pod, which is just a fancy word for a group of containers inside your AKS cluster. Now that app needs to talk to an Azure SQL database. How does it prove its identity to that database without, plastering passwords everywhere?
Well, the old way was kinda clumsy. You'd store credentials as secrets right inside the cluster. That is literally like leaving the key to the treasury under the doormat. If an attacker gets in, they get the key. The modern, much more secure way is something called workload identity. And honestly, you can just think of it as a magic key. It gets created for one specific task, and then poof, it disappears moments later.
So how does this magic key work? It's actually a beautifully simple 4-step dance. First, your app pod pings Entra ID and says, hey, I need a token. Then, Entra ID checks out the pod's identity, which you've already set up. If everything looks good, Entra ID issues a special, super short-lived access token. Finally, your pod takes that token, shows it to Azure SQL, and gets access. The best part? No stored secrets, no keys under the doormat, just clean, secure access.
Okay, we've secured the gates, we've secured the treasury. Now it's time to reinforce the actual walls of the fortress. This is all about making the entire cluster structure fundamentally stronger and way less exposed to the big bad internet. And there are 4 really critical techniques for this. First, private clusters. This makes the brain of your cluster, the control plane, totally invisible to the public internet. It's like taking your castle off the map. Second, restricting API server access. This is like building a virtual moat around your fortress, only letting traffic from trusted networks cross. Third, pod security standards. These are the rules about what's even allowed to run inside your walls. And fourth, network policies. Think of these as internal firewalls that stop your apps from talking to each other unless they're supposed to. It's great for damage control.
We have covered a ton of ground building our fortress. So now,
Let's boil it all down into the final blueprint. This is the architect's checklist you can and should use for every single production cluster you build from here on out.
This is it, your 5-point checklist for a Fortress-grade AKS cluster. Number 1, always integrate with Entra ID for authentication. 2, always implement least privilege RBAC. 3, always use workload identity, never secrets. 4, enable private cluster mode. And 5, restrict that API access to only your trusted networks. You follow this blueprint, I promise, you are building a very, very secure fortress.
So, there you have it. We've designed it, we've built it. The walls are high, the gates are guarded, the treasury is locked down tight. But security isn't a set it and forget it kind of thing, is it? So the final question I'm going to leave you with is this. Your fortress is built. Now, how will you defend it? Because the job of the architect is never, ever truly done.